So for number 8, we have a spherical balloon that's deflated so that its radius decreases at a rate of 2 inches per second. At what rate is the volume of the balloon changing when the radius is 3 inches? So again, this looks like a related rates question to me. We're talking about rates, and it says solve the related rates problem, the directions as well. So yeah, so this is definitely a related rates question. And so we want to figure out the situation and identify variables and then set up an equation, right? So first we want to think about, is there a shape involved? What shape is it? And so we're talking about a spherical balloon, so that's a sphere. And in terms of the aspects or elements of that sphere that are in play here, we're talking about the radius, right? And then we're talking about the volume. So we want to try to find a formula that relates the radius and volume of a sphere. And luckily we have one. So it's volume equals 4/3 pi r cubed. All right. So that's our formula. And taking care of all of our variables there. So now we can derive this with respect to time. So d dt. And remember that 4/3 and pi are just variables. Or excuse me, the opposite. 4/3 and pi are constants, I should say, is what I meant to say. And so they're not, it's not a separate function. There's no product rule we have to use here because r is the only variable that we're multiplying by in here. These are just constants, so we can just do constant multiple rule. So basically it's just going to be the power rule. We're going to multiply r by 4/3, and then we'll take away 1 from r, right? And so let me change the color there just to, so we're going to multiply 3 by 4/3, it's the same color. And then we're going to take away 1 from the 3, right? And get 2. So what will happen is 4/3 times 3 is just going to be 4, right? 3 cancels out. And then we're going to still have the pi. And then we're going to have r squared, right? So that's the power rule there. And the 4 and the pi basically are just getting multiplied by that exponent. And then don't forget to tag on the r prime, because implicit differentiation, right, and chain rule. And then on the left side, we have v prime, right, if we take the derivative with respect to time. So remember, v prime is dv dt, r prime is dr dt, the rate of change of volume and rate, respectively. All right, so now let's see if we can plug in information in the right places, okay? So we have the radius decreases at a rate of 2 inches per second. So that is going to be the rate of change of radius, right? So r prime equals 2. So we're going to put a 2 in here. Okay, then it says at what rate is the volume changing? So the rate of change of volume, volume is v, right? So the rate of change of volume is going to be v prime. So that's what we don't know, right? That's what we're solving for. Okay, and then it says when the radius is 3. So that's when r equals 3. So we're going to plug in 3 for r. All right, we're not going to put anything for pi. We're just going to keep it as pi because that keeps it exact. And so we'll end up with just v prime is the variable we're looking for. So we leave that how it is. And we have 4 pi multiplied by 3 and square it. And then we put in 2 for r prime. All right, so basically, again, we're just going to leave pi as it is. We're just going to multiply all these together. And so we want to do 3 squared first because PEMDAS, order of operations, right? So that's 9. 9 times 4 is 36. 36 times 2 is 72. So it's going to be 72 pi. Okay. And so that's our answer. Now we just have to assign units. And so in this problem, we're talking about inches and we're talking about seconds, right? And so if we're talking about the rate of change of volume, it's going to be some volume measurement over seconds because seconds are a time unit. And so in terms of volume, remember, it's always cubed. And so it's going to be inches cubed per second. So that's our answer to the rate of change of volume for this particular question.